Hey, it's Coach Latham, and today we're going to be reviewing for your Algebra 1 SOL test. And this first topic that we're going to cover is called justifying steps. So what we'll do is I'll talk while I'm scrolling through these problems, and then what I'd like for you to do afterwards is to go back, turn the volume down, and make sure that you can get all the answers right on your own. First thing we're going to talk about, which property is illustrated in this problem? Well, we're going to multiply 2 times x and 2 times 5 to get rid of the parentheses and to get 2x plus 10. So that one's going to be the distributive property. In this one, we have 2x plus 6 plus 3x, and then we have 2x plus 3x plus 6. So the order is changing in the addition problem. And when the order changes, that's commutative. So it's the commutative property of addition. In this one, we have 6x times 1 equals 6x. So we're multiplying by 1 and getting the exact same thing for the answer. So that's an identity. When you get the same thing for the answer, this is the identity property of multiplication. In this one, we have 3 equals x, like you might get at the bottom of an equation. And then we flip it around to say x equals 3. This is going to be the symmetric property. This one, we have x equals x, which seems kind of silly. You don't even have to think about it. This one is the reflexive property. Here we have 3 times 7 is equal to 7 times 3. So we're changing the order in a multiplication problem, and that's going to be the commutative property of multiplication. In this one, we have x plus 6 in parentheses plus 3 equals x plus 6 plus 3 in parentheses. So the order of the numbers doesn't change. Only the grouping changes. The parentheses move. It's an addition problem. So it's going to be the associative property of addition. Here we go from 2 times x times 3 in parentheses to 2 times x in parentheses times 3. Again, the numbers don't change. The grouping changes. So it's going to be the associative property of multiplication. Here we have 3x plus 5 equals 23. And how do we get to 3x equals 18? Well, we subtracted a 5 to each side, or we added a negative 5 to each side to cancel out the 5. Anytime you cancel something out, you're thinking inverse, and this one will be the inverse property of addition. Now, there's only 2 inverse properties. There's one for addition, and there's one for multiplication, which may be a little confusing. But think of addition and subtraction as fitting into addition, and multiplication and division as fitting into multiplication. Here we've got 3x equals 18. How do we get to the next step? Well, we divided both sides by 3, so this is going to be the inverse property of multiplication. Here we have 3x plus 0 equals 3x. Well, we started with what we ended with, and we added a 0, so this one is going to be another identity. It's the identity property of addition. When you add 0 to anything, you get what you started with. Here we have 7x minus 3 equals 18, and in the next step, I see 7x equals 21. What did we do to both sides? We added 3 to get rid of the negative 3, so it's going to be the inverse property of addition. Now here we have the next step in the problem, 7x equals 21, and we work our way to x equals 3. So we multiplied each side by 1/7, or we divided by 7 is the way we usually think of it. So that's going to be the inverse property of multiplication. X times 0 equals 0. Anything times 0 is 0. That's going to be A, the multiplication property of 0, which sometimes gets confused with this one. Here we have 2 things that multiply together to get 0. This is called the zero product property. Now we have an inequality, so this one's going to have to finish with inequality. We see these 3 do. And to get from this step to this step, we add a 6 to both sides to cancel out that negative 6. We're going to add to both sides of this inequality, so it's the addition property of inequality. This time we're going to divide both sides of the inequality by negative 2. So that's going to be the division property of inequality. And the one thing I'll point out to you right now is that when we divided by negative 2, it changed the direction of the inequality. Anytime you multiply or divide both sides of an inequality by negative, it changes the direction of the inequality. If A is greater than B and B is greater than C, then A is greater than C. We have three things being compared, like a tricycle that's always going to be transitive. And since these are inequality symbols, that's going to be the transitive property of inequality. Here we have three things being compared, and this time they're equals. So this one will be the transitive property of equality. Here it says to solve this equation for P by correctly using the division property of equality. That means we're going to divide both sides by Q in order to get P by itself. And so when we do that, the answer is going to be A. P is equal to negative 18 over Q. We're going to say, we're asking which one of these four is the correct application of the distributive property up above, which means we're multiplying out the 3. The one that's correct is C, because 3 times 2x is 6x, and 3 times 5 is 15. This one says that you start with negative 3x is less than negative 12. We're going to divide both sides by negative 3. So when we do that, it's going to give us x on the left, and negative 12 divided by negative 3 is positive 4. But you also need to remember that if you divide by a negative, it flips that inequality symbol, so the answer is D. Here we go. Which of the following correctly applies the addition property of inequality? So we're adding an 8 to both sides. 12 and 8 is 20. So the answer will be A. 3x is greater than 20. So those are the properties that you will need to use to justify steps. Please make sure that you turn the volume down, go back, run through them again, and hit pause to see if you can get them all correct. Good luck and keep studying for that SOL.